Good morning, viewers. This is Kasturi Day. Today, I'm going to discuss again, rather continue with the discussion of the language of chemistry chapter according to ICSE syllabus class 9. Okay. So in my last few videos, I was discussing about this this language of chemistry, where in my last video, I discussed about the certain compounds and how to name them certain compounds, then what is the formation, significance, importance of the chemical formula, and how a chemical formula is written like that. Okay. So now I'll start with how the valency is calculated from the given formula. Okay. So before starting, I would request you to stay tuned with my videos so that you can get the updation of these videos, where I will discuss some ICSE pattern question answers of this class 9 syllabus only. And I'll give you some homework also for that, for solving these problems. And also, press the like button to so that it can motivate me to produce you good videos, and that can help you in your studies. And also do share with your friends so that they can also be benefited from these videos, and obviously go through the videos. Okay, so let me start with today's video. So the valency of an element of elements can be determined based on the knowledge of the valencies of the radicals and of the elements. Okay, so what is the the valency of the radicals? What is there that has to be that we have to know it? Like hydrogen has a valency of 1, oxygen has a valency of 2, chlorine has a valency of 1. Okay, so to calculate the valency from the formula, for example, see if the given formula is NO2. So while interchanging the subscripts, we write it as superscript, that is N2O1. Okay, see the formula, given formula is NO2. The subscript is N1 and O is 2. And when interchanging it, we write the superscript as, subscript as superscript, like N2O1. Now the valency of oxygen is taken as 2, and then multiplying both the subscripts by 2, we get N is equal to N4 and O2. Okay, so the result is the valency of the elements. That is, N has 4 valency and O has 2 valency. And therefore, the formula NO2, the valency of nitrogen, from the formula NO2, the valency of nitrogen is 4 and oxygen is 2. Okay. So next one, we come to chemical equation. Okay, this I go to the previous slide, where see, this is just the opposite when we are forming a formula. No, just check once. See here, when we were forming a formula, see F2O3, we were writing it like that. So a ferric oxide was there. So that time ferrous, iron had 3 valency and oxygen has 2. Okay, so now after dividing it by HCF, we found it remained the same, because 3 and 2, there's no common highest factor. Okay, and after exchanging their valencies, we get F2O3. Okay, Fe2O3, therefore the formula becomes Fe2O3. Like that, this is just the opposite in case when we are finding the valency from the formula. See, NO2 is given, the formula is given, and we are exchanging the subscript and writing it as superscript, and then we are multiplying them. That there we were dividing by highest common factor. Here we are multiplying both the superscripts by 2. Okay, by a common factor, and therefore we are getting is this way. Nitrogen has a valency of 4. Now we come to the chemical equation. It's a symbolic representation of a chemical reaction. What's a chemical equation? It is a symbolic representation of a chemical reaction using what? What do we use? We use formula of the substances involved in the reaction. Okay, we use symbols in the formula of the substances which are involved in the reaction, in the chemical reaction, and represent that chemical reaction in a symbolic way. Like, for example, burning of coal in the air, which produces carbon dioxide. Okay, now word equation is coal, that means carbon, and burning in air, that means it's burning in oxygen. So coal plus oxygen in presence of heat, as it is burning, so heat is required. So in presence of heat, it is producing carbon dioxide. So chemically, we can write symbolically, we can write C plus O2 in presence of heat becomes CO2. Now, steps to write a chemical reaction. What are the steps we should follow before writing a chemical reaction? First, we write the symbols, so the formula of the reactants on the left-hand side, and we put a plus sign between them. See, from the left-hand side, we write the reactants formula or symbols, and also write a plus sign, okay, between the reactants. Okay, now writing the symbols or the formula of the products on the right hand side. This is the left hand side. We have written the reactants. On the left hand side, we write the products on the right hand side, and if it is more than 2, then we put a plus sign between them. Now between the reactant and the products, we put an arrow symbol. Okay, this is an arrow sign in between the reactants and the product side. Now, representing the reactants and the products in the molecular forms, as their atomic forms are not stable and cannot exist independently. So we we write the reactants and the products in their molecular forms and not in the atomic forms, because atomic forms are not stable and they cannot exist independently. So we write in the molecular form. For example, see, sodium reacts with water to form sodium hydroxide and hydrogen. So see, we write the molecular form, that is Na plus H2O, and we get NaOH plus H2. We cannot write in the atomic form as H. Okay, we need to write as H2 because it's a molecular form. So like that, this is the reactant side. We put a plus sign between them, and this is the product side, and we put a plus sign between them. Okay, more than one product is formed. Then we put a arrow sign between the reactant and the product side. Okay, this way we write a chemical equation, and then we balance them also. Okay. Now, chemical reactions may involve one reactant and 2 or more products. This can also happen like this. For example, this one, see, one reactant, calcium carbonate, and 2 or more products. That is, 2 products are here formed, calcium oxide and carbon dioxide. So there is a plus sign between the 2 products. Now, the chemical reaction it can be 2 reactants and 1 product also, like ammonia and HCl, hydrochloric acid. The 2 reactants are there, so there is a plus sign between them. And the product is only 1, that is ammonium chloride. Okay, then 2 reactants and 2 products, like silver nitrate and sodium chloride. So plus sign between them, there's an arrow between the reactant and the products, and the products here are 2 products are formed. See, silver chloride and sodium nitrate. Then 2 reactants and 3 or more products is formed. This can also happen. See, 2 reactants are there, but the products are here 3 or more. So here 4 are formed. So 2 reactants are, see, potassium permanganate and hydrochloric acid gives us potassium chloride. There is other products, potassium chloride, manganese chloride, water, and chlorine. So chemical equation are of 2 types. Okay, first is skeletal equation and the balanced equation. The skeletal equation, what we write from the word equation without balancing them. And the second part is the balancing the equation. Okay, like see, if we write this equation, the fourth equation, KMnO4, 2 KMnO4 plus 16 HCl gives us 2 KCl, 2 MnCl2, 8 H2O, and 5 Cl2. This is a balanced chemical equation. But if we write the equation in this way, just after reading the word equation, if we write like this way, KMnO4 without writing the 2 plus HCl without writing 16, then KCl gives us KCl, MnCl2, H2O plus Cl2 without writing the numbers like 2, 16, 2, 2, 8, 5. We don't write these. Okay, then this becomes a skeletal equation. Now I'll discuss what exactly we mean by skeletal and what exactly we mean by balanced equation. That is the difference between them. Now, see, skeletal equation as an equation, it's an equation that represents a chemical change which is not balanced. Or in this equation, the total number of each element on the two sides are not equal. Okay, the total number of the elements of each element on the reactant side is not equal to the total number of elements on the product side. That is a skeletal equation that is not balanced. Okay, like for example, this is a skeletal equation. KNO3 gives us KNO2 plus O2. See, K is okay, N is also okay. O here is in the reactant side, it's 3, but in the product side, it is 4. So this is unbalanced equation, or you can say the reactant side is not equal to the product side. So that is a skeletal equation. Now we come to balanced equation. Balanced equation is one that represents a chemical change which is balanced, or an equation in which the total number of atoms of each element in the reactant sides on the left-hand side of the equation is the same as the number of atoms in the products formed on the right-hand side of the equation. The next step of this example, see, we balance it with like this, 2KNO3. Why? And then 2KNO2 and plus O2. Why this happened? See, we made by multiplying this whole reactant side into 2. Then what we see the potassium, that is K, becomes 2, N becomes 2, and O becomes 6. 3 into 2, that's 6. Now we check in the product side. In the product side, we see potassium, that is 2K, then 2N, and O, here it becomes 4. 2 into 2, 4, plus O2, that is 2, then 6. So oxygen here, this side, that is reactant side, is also 6, and also in the product side, that is also 6. So the equation becomes balanced. Okay. Next, we come to some balanced equation, how to balance an equation. Okay, an equation is balanced to comply with the law of conservation of matter. Okay, so we know that matter is neither created nor destroyed in a chemical reaction. To maintain that, okay, to follow the rule of this matter, we use a law that is known as law of conservation of matter. Okay, so the matter is not created nor destroyed. For that reason, we balance the equation. But if the equation remains unbalanced, then it would indicate that atoms have been created or it has been destroyed. Okay, so to follow this law, we need to balance the equation. And for that reason, for balancing that equation, there are two methods, heat and trial method and partial equation method. Two methods are used. Okay. First, we come to heat and trial method. In this method, in which the number of atoms of each elements on both the sides are counted to equalize them. Okay. First step is we equalize them on both the sides. First, the number of times the frequency of an element occur on each side are counted. See, we made a table here. First, we write the elements which are used, that is in the reactants, and the products which are formed. Now, the product elements. Now, first we write all the elements, that is magnesium. See, magnesium is there, hydrogen is there, chlorine is there, and oxygen is there. Okay. Now, on the reactant side, magnesium, we need to count the number of atoms now. Magnesium, number of atom is 1. Hydrogen, see 2, and this is 1. So 3. Chlorine is 1, and oxygen 2. Okay. Now we see on the product side, that is on the right hand side. Magnesium 1, chlorine here is 2. Okay. Oxygen here is 1, and hydrogen is 2. Now we compare the right hand side, that is left hand side and right hand side both, reactant side and product side. See, magnesium on the reactant side it's 1, product side is also 1. Okay. Then for hydrogen, reactant side it is 3, product side it is 2. Chlorine, reactant side is 1, product side is 2. Oxygen, reactant side is 2, and product side is 1. So what do we do? There's some unbalanced situation is there. So we need to balance it. So what do? We first, the element with least frequency of occurrence is balanced first. Okay, so chlorine is first balanced. So to balance it, 2 is inserted before HCl on the left-hand side. Left-hand side, on the reactant side, first we use the chlorine because it is the least frequency of occurrence. So we multiply HCl with 2. Okay. So what happens? We see that here hydrogen becomes 2 and also 2. So the reactant side, hydrogen becomes 4. And on the product side, hydrogen is still 1. But chlorine here it becomes 2. Product side it is chlorine is 2. Okay. Next step, we need to change here the product side, hydrogen should increase. So what do we do in the product side? Then oxygen, that is O, is balanced by inserting 2 before H2O on the RHS, that is right hand side. So we insert 2 before H2O. See the blue color, 2 is inserted before H2O. Okay, so we write MgOH2 whole twice plus 2HCl plus MgCl2 plus 2H2O. Then we see that hydrogen, both the sides, it's 4. Here it's also product side is also 4. Okay, chlorine, both the side is 2. Oxygen, both the side is 2. Okay, magnesium is also both the side it is 1. So then the number of atoms of hydrogen is checked. It is found that it is getting automatically balanced. When 2 or more elements have the same frequency, the metallic element is balanced first. Okay, this is the rule. When we first start balancing, we should take the least frequency of the occurrence of the element, and then we start balancing that first. Then if 2 or more elements at the same frequency, then the metallic element is balanced first. Okay. So this is how the total, this equation is balanced by hit and trial method. Okay. Then partial equation method. Here what we do, it is a method of balance equation by supposing the complex reaction to take place in steps. We consider that the complex reactions are taking in the steps. And in this method, the equations are written in steps and then they are added. For example, see oxidation of halogen acid to halogen by ozone. So halogen acid, that can be hydrochloric acid. Halogen acid, halogens are chlorine, fluorine, chlorine, iodine, and bromine. These are halogens. So any acid which contains chlorine, fluorine, bromine, or iodine, that is halogenic acid. Okay, so ozone is O3 and halogen acid is oxidized to halogen. Oxidation involves removal of hydrogen or addition of oxygen. Okay, so when an acid is oxidized, that means it has hydrogen that is removed from its acid, and the non-metal is separated from it. Okay, so the acid gets oxidized. Then ozone decomposes to nascent oxygen. Okay, ozone decomposes to nascent oxygen. Ozone has O3. So O3 becomes nascent oxygen, that is O2 plus O, which that is simply O, which is called nascent oxygen. Okay. Now, HCl is an halogen acid which gets oxidized to chlorine Cl2 by this nascent oxygen, which has been decomposed from the ozone. Now, on adding both the equations, what do we see? O3 is decomposed to O2 plus O, that is nascent oxygen, and this nascent oxygen reacts with HCl to form H2O, and chlorine gets separated. Okay. Now, this equation, the second equation, HCl plus O gives us H2O plus Cl2. Here, see, H2 and Cl2 is there. So we need to, in the product side. So this reactant side, we need to multiply HCl with 2. And nascent oxygen, here it's 1 O, and therefore this one is also O. On adding both the equations, we get 2 HCl plus O3 gives us O2 plus H2O plus Cl2. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. You can also refer to my email ID, that is kasturi74@gmail.com. Okay, and please send your personal email ID so that I can reply you in your personal ID also. Okay, so explain it and send it to you. Okay, and as usual, I'll tell you to go through the videos and stay tuned, do subscribe to my videos so that you can continue with my discussion. And also I'll be next I'm updating in my videos. You are able to know that. Okay, that is, now I'm telling that I'll be discussing some ICSE pattern question answers, and I'll give you homework. So these things will be there, so you can continue. You can have a practice of this question answers before your exams. Okay, and also do press the like button so that that can motivate me to produce your good videos, and also do share with your friends so that they can also be benefited from these videos. Okay, thank you for watching, and have a good day.